Hi everybody, welcome to another video in trigonometry. We continue in section 7.2 law of size. In this case, we focus on the ambiguous case. So the ambiguous case. So, if we know the length of two sides of a triangle and the measure of a non-included angle, that means two sides but the angle is not in between. In that case, we might have one solution, no solution, or two solutions. Right, so once again, we know the two sides, meaning we know this side and we know this side, but we also know the angle, but not in between the two sides. That is the case of side, and angle. I mean two sides and angle is not in between. So in that case, we may have, for this case, this side is not long enough to form a triangle. In this case, it's just enough to form a triangle. In that case, one solution. Or when the case where A is just long enough, so we will have two solutions. One's here and one is here. So two triangles. And if it is too long, it will be just one triangle. So no solution if it is too short. If it is too long, there's two. If it is just right, there may be one solution when there's the right triangle. Or there may be two. So that is the case where there's acute angle. Obtuse triangle, we may have one solution or two solutions. One solution or no solution. So bottom line is where we have two sides and an angle, but the angle is not in between the two sides. That is the case where we have to watch out for the side, angle. That's what we need to watch out for. It might have two solutions, one solution or no solution. Right, so let's look at this example. So still using law of size though. You see why just in a minute. Right, let's just draw it. So in this triangle, what we have is A, B, C. Angle C is 62 degrees. We know sine A, which is opposite to A, is 50. And C, which is opposite from angle C, is 100. So sine C is opposite to angle C. C is 100. The angle C is 62 degrees. Sine A is 50. So A is opposite to A, C is opposite to sine C. Oh, that's good then. Now let's just put the information in the triangle. Now what we have in this case is two sides and the angle is not in between the two sides. So this is very important that we recognize right away when we have two sides and the angle is not in between. This is the side angle. Once again, I said don't spell this backward. That case is where we have no solution, one solution or two solutions. Just in case, potentially that could be two solutions. So I'm going to draw another table just in case there might be two. Let's put information we have. Angle C, 62 degrees. Sine C, 100. Sine A, 50. Of course, when we have this, that is the law of sine, right? Opposite sine angle. Right. I'm going to do both because potentially we might have two solutions. Right. And then A equal to 50. Right. Regardless, opposite of sine angle, that is the law of sine. Right. So we set up the law of sine. Of course, in that case, we will determine A, angle B, angle A, and sine B. Potentially, we might have two solutions. So just prepare for both of those scenarios. Right, set up the ratio. One thing for sure, we're not going to use B because we don't know angle B, we don't know sine B. That ratio is useless. So let's just write out sine of angle A, which we don't know, over 50. Right. Sine of B over B, like I said, that ratio is useless because we don't know that, but regardless, just write that out. And sine of 62 degrees over 100. Definitely we need to use this ratio because we know both sine angles. Right, so cross multiply, and we have not going to use that. So cross multiply in here. 100 sine A equal to 50 sine of 62 degrees. So we can get sine A equal to 50 times sine of 62 divided by 100, right? Because the only emission information here is the angle A. So 50 sine of 62 over 100. Once again, make sure it is in degree mode before we do any calculation. So 50 sine of 62 divided by 100. We have that. Right. Now, you remember that when we have sine equal to something, if we want to get back to it, there will be two solutions, either the sine inverse or the supplement to it, right? So in that case, we have maybe two scenarios here. One of which A equal to sine inverse of whatever that ratio is. Right, so this is in degree mode, sine inverse of that. We have 26.2 degrees. Or the supplement from it. Supplement, of course, subtracted from 180 degrees. And we just take 180 minus this. That's 153.8. Right, so that's what we have. Now put both of those information into our table, potentially solution. Potentially solution, we might have two, so we're just going to do both. First angle A is 26.2 degrees, and angle A is 153.8. Right. At this step, we know it's not going to work, right? I mean, this is not going to work. For one, the angles add up to 180 degrees. This is more than 180 degrees already. That's not going to work. So that's the first. Second, this angle is bigger than that angle. This side should be bigger than that side, which is not the case here. Bigger angle face the longer side, which is not. So in this case, this scenario is not true. So in that case, we're just going to cross that out. But this solution doesn't work. Or this Parkhurst solution doesn't work. So we have one solution here. So 26.2. Now we know all three angles, so we can find the last angle. So from here we can solve for angle B, 180 degrees minus 62 minus 26.2. And that gives us 91.8 degree. Right. Now, in order to find sine B, we need to go back to law of sine. And now we know the angle, so we can find B. Now put everything in the law of sine. Sine of 26.2 over 50 equals sine of 91.8 over B, sine of 62 degrees over 100. Of course, we can use either the first ratio or the last ratio to calculate for B, but I'm going to use the last ratio because in this case 62 degrees is given, 100 is given, so it is better to use what is given and not what is derived. Having said that, the 91.8 is calculated already, so that's still not the best option, but at least both of these are given. So we're going to cross multiply and then we solve for B. This will be easy. Yeah. Right, so we get B equal to 100 sine of 91.8 over 60 sine of 62 degree. (100) sine of 91.8 divided by sine of 62.2. It is 100. Yeah, let's round to 1 decimal places. Right, so simple enough. So once again, calculation, make sure it is in degree mode. And then we'll final check. The angles add up to 180. Biggest angle face longest side, smallest angle face the shortest side. So let's check. So Most of this problem potentially we have two solutions. So that's why we write two tables. Every time we have two sides, but the angle is not in between. So that's where we have two solutions, no solution, or one solution. Right, another example here. Let's draw that out. So in this case, we are given angle C of 40 degrees. Sine A is 3.3. And sine C is 2.1. But we don't know sine B. Right, so what we are given here? We know this side, and we know this side. Sine, the angle is not in between. So in this case, we have sine, and the angle is not in between. If this is the case, we may have two solutions. We have one solution, or we might have one solution. So in this case, just draw two tables because we might have two solutions. Every time we have sine angle, we might have two solutions. Just prepare for both. Right, now let's write all the information we have. Angle C, 40 degrees. Sine C, don't know. Sine C actually 2.1, we do know that. Sine A, 3.3. So that's all we know. The others, we don't. A, B, little b, and then potentially we may have two solutions. Right, regardless, we have a pair of opposite angles in sine here, so that is the law of sine. So law of sine, let's write out the ratio. Sine of A over sine A, which is 3.3. Sine of B, we don't know the angle, we don't know the sine. Sine of C, angle C, over sine C. Of course, the middle ratio is useless because we don't know either angle or sine. But definitely we will use the first and the last. Because we know both of them. So cross multiplying here, sine of A equal to 2.1 sine A equal to 3.3 sine of 40. So from here we can get sine A is equal to 3.3 sine of 40 over 2.1. Once again, make sure it's in degree mode. 3.3 sine of 40 degrees divided by 2.1 give us 1.1, 1.01. Right. If sine equal to values, there will be two potential solutions. One of them is the sine inverse. The other one is the supplement to that, meaning subtract from 180. Right, sine inverse of that should be no solution because sine is supposed to be between -1 and 1, right? So that's why it's no solution. So in this case, we can say no solution. And this, of course, also no solution because this one is, again, it's undefined. So this one we have no solution. Right? Yeah, so be prepared for both. When we have the sine angle. Right. Yeah, you get that idea if in the note I didn't have a lot of space for that. I have a lot of space for the next one, so more like the next one we might have a long solution. Anyway, so that is that. Next, draw a triangle again. A, B, C, angle A, 42 degrees. Sine A, 55. Sine C, 62. Right. So in this case we have a sine here and a sine here. So knowing two sides, but the angle is not in between the two sides. So we have two sides, the angle is not in between. So in that case, this is the sine angle situation. In that case, it might have two solutions. So be prepared for both. Be prepared for both. Right. Put in the information we have. Angle A, we do know 42 degrees. Sine A is 55. Of course, when we write this, it screams log sine because opposite angle and sine. Sine C, 62. Don't know A, don't know angle B, don't know sine B, don't know angle C. Right, do the same thing here. Right. Once again, a pair of opposite sine angle. This is law of sine. So let's write out the law of sine. Sine of angle A, 42 degrees, over 55 equals sine of angle B. We don't know sine B either. Sine of C, don't know angle C, but we do know sine C, 62. Right. The middle ratio is useless because we don't know either sine or angle. So we use the first ratio and the last ratio and cross multiply. 55 sine of C equal to 62 sine of 42 degrees. In that case, we can get to sine of C equal to 62 sine of 42 degree over 55. Degree mode, yep, 62 sine of 42 degrees divided by 55. 0.754. But just write that because when we do the calculation, let's use the whole number. Don't just round off and then just write 4 decimal places here. Now sine equal to a values, there are two scenarios, either the sine inverse or the supplement to that. So there might be two scenarios here. Sine inverse, sorry, C equal to sine inverse of that 48.96. Yeah, let's keep 2 decimal places. I'm going to put it in here, 48.96 degree. Or here we have the supplement to that. Supplement meaning subtract from 180. That's 131.04. Right. Now let's check. Bigger angle face the longer side, so that check. Bigger angle of the two face the longer side, so that check. Both of them check. Also, the angles add up to 180. So when we add these two, there are room left for B. When we add these two, there will be room left for B. So in this case, there's two solutions. Again, we use two things to check. All the angles add up to 180 degrees, and the bigger angle face the longer side. If both of them check, we might have two solutions, which we do have in two solutions here. Right. So A plus B plus C is 180 degrees. So here we can get B. Angle B is equal to 180 minus A minus C. 180 minus angle A of 42 minus angle C of 48 point something. I just copy and paste here. So that's 89.04. Right. And then of course from there I just need to find angle B. I need to find sine B, law of sine. Now we know almost everything. Angle B now we know is 89.04 degrees. Sine B we don't know. Sine of C 48.96. C is 62. Of course, we can use either the first or the last ratio, but I will use the first ratio because 42 degrees and 55 are both given, which is more accurate than the round off here. Right, cross multiply, then we can solve for B. B sine of 42 degrees equal to 55 sine of 89.04 degree. So we get B 55 sine of 89.04 degree or sine of 42 degree. Once again, degree mode. 55 sine of that. Actually, I have that values, so just copy and paste those numbers. If your calculator cannot do that, you have to copy the whole numbers. To make sure that the more decimal places, the more accurate answer we have. And we only round anything at the end. 82.184 something. So again, I will round at the end. 82.18. Right, now let's check. Biggest angle, longest sine, smallest angle, shortest sine. They add up to 180. Yep, that's good. Yeah. Right, so this is one solution. Let's go to the other. Once again, we know two angles. We should know the last one as well. So angle C, which we know, we just need to know angle B. (180) minus A minus C. Right, 180 minus angle A of 42 minus angle C of 131. We actually have that number here. Copy and paste. Yeah, just if your calculator can do that, just go, when you highlight the number, hit enter, just go up, highlight the number, hit enter, it will copy and paste. Yeah, if your calculator cannot do that, we just have to copy the number manually by typing this number. But here we have B is 6.96 degree. And now use the law of sine again for that table. Sine of 42 degrees over 55 sine of 6.96 degree over B, which we don't know, sine of 131.04 degree over C of 62. Right. I will use the first ratio because those two numbers are given. This number is calculated and I round off. So use the first two ratios. Cross multiply B sine of 42 degrees equal to 55 sine of 6.96 degree. So B equal to 55 sine of 6.96 degree over sine of 42 degrees. 55, it is in degree more, yep. 55 sine of 6.96 I will use the whole numbers, that will be better. Divide by sine of 4.2 degrees. I mean 42 degrees. Right? 9.965, so let's say 9.96. And that is sine B. So this, they add up to 180 degrees. We can check that. Biggest angle, longest sine, that's good. Smallest angle, shortest sine, so that check. Yeah. So in this case, we have two solutions. So once again, always draw the triangle out, and when we have the two sides and the angle that is not in between, it is the ambiguous case where we have no solution, may have no solution, one solution or two solutions. So prepare for both of them. And use law of sine because we have a pair of opposite sine angles. And then solve for the angle involved in the sine inverse or the supplement to that. We may have no solution directly from it, or we may have two solutions. Or from the first example, we have just one solution because when we do that, the angles here add up to more than 180 degrees. So that's why that solution doesn't work, and we have one solution. So once again, when we have two sides and the angle is not in between, that is the case when we may have no solution, one solution or two solutions. Just write out two tables because they might be both. Right. Both cases, one of them is the sine inverse, the other one is the supplement of the sine inverse. And then we'll just work out both of them. Check to see if both of them are correct. Maybe one of them will work, maybe both of them will work, maybe none of them will work. But that's what we have in this section, where we have the sine angle scenarios. Anyway, I will stop the section here. As always, thank you for watching, and see you in another video in trigonometry.